Hello, this is Nishita from NYU Poly, and I'm making this video as part of my homework for probability and stochastic processes EL-6303, and this is for homework 3. The question 1 for homework 3 says P of x is equal to k is equal to a into k into 1 by 3 whole to the power of k minus 1, where k takes the value 1, 2 up to infinity. The sub question A is to find A so that the value of P at x is equal to k represents a probability mass function. So in order to represent a probability mass function, we know that the sum of all the terms must be equal to 1. So we take summation of x, k is equal to 1 to infinity, a into k into 1 by 3 whole to the power of k minus 1 is equal to 1. So here we have taken a out, and we have taken summation of k is equal to 1 to infinity, k into 1 by 3 whole to the power of k minus 1 is equal to 1. So if we substitute the values from 1 to infinity, we'll have a into 1 by 3 whole to the power of 0 plus 2 into 1 by 3 plus 3 into 1 by 3 whole square and so on is equal to 1. So if we divide and multiply the LHS with 1 by 3, we'll get a by 1 by 3 into 1 by 3 plus 2 into 1 by 3 whole square plus 3 into 1 by 3 whole cube and so on is equal to 1. So if we cross multiply, we'll get this equation. And we have a general equation for integration of summation of k is equal to 1 to infinity k into a to the power of k is equal to a by 1 minus a whole square. So if we substitute this here for a is equal to 1 by 3, we'll get a into 1 by 3 by 1 minus 1 by 3 whole square is equal to 1 by 3. On solving this, we'll find that the value of a is equal to 4 by 9. So the second part of the question asks us to find E of x. So we know that E of x is equal to integration of k is equal to 1 to infinity k into the given equation, which is a into k into 1 by 3 whole to the power of k minus 1. Again, we have taken a common out, so it will come to we have substituted the values of k. So it will come to a into 1 by 3 whole to the power of 0 plus 4 into 1 by 3 plus 9 into 1 by 3 whole square and so on. So we have multiplied here we can multiply the LHS and RHS by 1 by 3. So we'll find 1 by 3 into E of x will be a into 1 by 3 plus 4 into 1 by 3 whole square plus 9 into 1 by 3 whole cube. So this can be taken in form of a general equation for which we already know the summation, which is summation of k is equal to 0 to infinity k square into a to the power of k is equal to a square plus a by 1 minus a whole cube. So if you substitute that with a is equal to 1 by 3 and then solve the whole equation, you'll find that you'll end up with 1 by 3 e of x being 2 by 3. So 3 gets cancelled on both sides, so E of x will be 2. So the third one is we have to find E of x square. So similarly, instead of k, we replace k by k square here. So it will come to summation of k is equal to 1 to infinity k cube into a into 1 by 3 whole to the power of k minus 1. So again, we have substituted the values of k is equal to 1 to infinity here, so it will come to a into 1 plus 8 into 1 by 3 plus 27 into 1 by 3 whole square and so on, and take this equation as a. So if we divide both LHS and RHS by 1 by 3, we'll find 1 by 3 into E of x square will be a into 1 by 3 plus 8 into 1 by 3 whole square plus 27 into 1 by 3 whole cube and so on, and I have taken this as b. So what you do is subtract a, take a minus b. So you'll end up with 2 by 3 E of x square is equal to a into 1 plus 7 into 1 by 3 plus 19 into 1 by 3 whole square and so on. So if we take the tail terms, it will come up to 3k square minus 3k plus 1 into 1 by 3 whole to the power of k minus 1 minus k cube into 1 by 3 whole to the power of k. So save this equation as equation C. So if we divide the equation C by 1 by 3 again on both sides, you will end up with 2 by 9 into E of x square, which is a into 1 by 3 plus 7 into 1 by 3 whole square, and similarly the tail terms will be 3k square minus 3k plus 1 into 1 by 3 whole to the power of k minus k cube into 1 by 3 whole to the power of k plus 1, which we have again taken as d. So if you subtract d from c, that is if you take c minus d, you will end up with 4 by 9 into E of x square is equal to a into 1 plus 6 into 1 by 3 plus 12 into 1 by 3 whole square and so on, 6k minus 6 into 1 by 3 whole to the power of k minus 1 minus k cube into 1 by 3 whole to the power of k plus 1 minus 3k square minus 3k plus 1 into 1 by 3 k plus 1 plus k cube into 1 by 3 into k plus 2. So what we can see here is k, as k tends to infinity, like because 1 by 3 is very much smaller than 1, we have a smaller term which is raised to a very higher power. So all these will tend to go to 0. So we can actually remove these terms as k tends to infinity. So if we remove those terms, we'll end up with 4 by 9 into e of x square is equal to a into 1 plus 6 into 1 by 3 plus 12 into 1 by 3 whole square, and take the last term as 6. This is we take this as the last term and remove all the terms above this. So we take 6k minus 6 into 1 by 3 whole to the power of k plus 1. So if you divide this, if you take this equation as e and then divide it by 1 by 3, we'll end up with 4 by 27 into e of x square, and again you add 1 by 3 for all the terms, and then you subtract, you take this equation as f and then you subtract e and f. So we'll end up with 8 by 27 into e of x square is equal to a into 1 plus 5 by 3 and so on terms. So again, like similarly as we did before, as k tends to infinity, we can take off these terms. So it comes to 8 by 27 into e of x square is equal to a into 1 plus 5 by 3 plus 1, and all of these terms are taken as 0. So if you resolve this equation, you'll end up with e of x square is equal to 11 by 2. Or you can take this as 5.5 also. So part D asks us to find the probability of x is equal to k as a conditional probability where x lies between x is between 1 to 10. So we know that for conditional probability we can take it as p of x is equal to k divided by p of x from 1 to 10. So we already know this because this is given in the question. So we just substitute by a 4 by 9 into k into 1 by 3 whole to the power of k minus 1. For p in between 1 to 10, we can take it as a summation of the terms from k is equal to 1 to k is equal to 2, k is equal to 3, and similarly up to k is equal to 10. So we take it as 4 by 9 into summation of k is equal to 1 to 10, k into 1 by 3 whole to the power of k minus 1. So this denominator value, we have done that in the previous question, previous sub answers A and B. So we can take the same evaluated values for this. So it becomes 4 by 9 into integration of k is equal to 1 to 10, k into 1 by 3, k minus 1 can be taken as 9 by 4 into 1 minus 1 by 3 whole to the power of k minus 3 by 2 into 1 by 3 whole to the power of k. So we know k here is 10. So we substitute the value of 10. Again, 1 by 3 is very much small compared to 1, and if you raise it to the power of 10, it is pretty much almost equal to 0. So take these terms as 0, it becomes 9 by 4 into 1, so pretty much equal to 9 by 4. So if you substitute that in the previous equation, so you will get p of x is equal to k divided by 4 by 9 into 9 by 4. They cancel out, so it is p of x is equal to k, which is nothing but 4 by 9 into k into 1 by 3 whole to the power of k minus 1, where k takes the value of 1, 2, 3 and up to 10.